Hello, my name is Röben². Thank you for your interest in my poster. This work is part of a French-German research cooperation. Our goal is to realize absolute power measurements in the WR-3 band. That means for us around 300 gigahertz. Because at these frequencies no calibration is currently available worldwide. We come basically rather from the higher frequencies, above 1 terahertz, where we already established a way to measure traceable to the International System of Units, the terahertz power. And our approach here to realize that with 300 gigahertz is to use such a free space power detector and put it in simple words right in front of an emitting horn antenna. So we measure the radiation that is emitted directly from the horn antenna. So here I show these already established terahertz detectors. These are pyroelectric thin film directors, which are also coated with a thin absorptive film. And these have the special property that they have, you can basically, we say wavelength independent responsivity from 100 gigahertz until 5 terahertz. We also need a source for these type of investigations. So we use the source of our cooperation partner, Lighted. The detectors are also from a company, from a German company, SRT. Lighted is a French company. This is the source Terra Schottky, which is based on frequency doubling using Schottky diodes. Here I show on the bottom our two approaches for the detection, because the main challenge is to avoid standing waves, because a special property of this standard coating of our detectors is that you have 25% reflection. And then, of course, if you put it directly here in front of the antenna, you get standing waves, you get interferences. So one approach is to adapt the coating so that you get very low reflection. That means below 1%. And the other approach is to use a standard coating with 25% reflection, but use such an oblique geometry so that all reflected radiation is then directed towards an absorber. And this is still a work in progress. We like this approach a lot, maybe even a little more than this one, because with that we can suppress reflection toward the antenna even below 1%. So we are focusing at the moment on this approach, and the goal is to establish traceability for power measurements at 300 gigahertz. Thank you.